An important type of spatial analysis, not just for conservation, but for many types of applications, is to understand the spatial distribution of occurrences. These occurrences are the geographic coordinates where we know an object or a phenomenon was seen or can be found. In conservation, we can use these analyses to understand why a species might be concentrating in a particular place or avoiding other areas altogether. This type of information about the spatial distribution of features can reveal insights about the underlying processes that generated the patterns, such as the environmental or human factors that may have influenced those locations. For example, you might have a point file for the locations of shark attacks that have occurred off the coast of Florida. And you might want to know whether these attacks are concentrated in a particular area or whether they are simply occurring at random along the coast. This information can help lifeguards decide whether to limit swimming at certain beaches, but it can also help marine biologists understand whether there might be environmental factors, like certain types of fish or warming trends in the ocean, that are attracting sharks to certain places. One of the simplest and most straightforward ways to measure the characteristics of spatial data is to identify where the center of activity is located and how the features are spread out around that center. The mean center is a simple statistic that identifies the geographic center of a set of features using their x and y coordinates. It averages the x coordinates and y coordinates and creates a new feature for the mean center. The map you see here is an example of a mean center analysis for how the U.S. population has shifted since 1790. The map is based on data from the U.S. Census, and the mean center for each decade was computed from the x and y coordinates of every single person living in the United States. In 1790, the mean center of the U.S. population was located near Kent, Maryland, but over time it has been steadily moving west. Starting in about 1940, it also started to shift south while continuing to move west. From these patterns, we can start to think about the processes that might be driving these trends. Before the 1930s, air conditioning was not widespread, but window air conditioning units were invented in 1931, making it much more feasible for people to live in southern climates. This development is likely one factor driving that trend we are seeing in the population mean center over time in the United States. The map of the U.S. was based on XY coordinates for every person surveyed in the U.S. Census. However, for conservation applications, we often need to account for more than one feature at each location. A good example is the popular community science app called eBird, which allows users to log the types of birds they see at specific locations. The different colored dots you see here symbolized in the map are based on the number of species that have been logged for a particular location. If we want to know the mean center of all of the surveyed birds, we need to account for this multiple sampling at each location. So certain dots should receive more weight than others. In these instances, a weighted mean center can be used to weight the locations with multiple birds more heavily than those where only one bird was seen. Locations with red dots would be weighted more than locations with blue dots in order to account for the larger number of species at red dot locations. In addition to mean center and weighted mean center, standard deviational ellipses are also helpful tools for understanding the spatial distribution of points. A standard deviational ellipse allows you to check if the distribution of features is oriented in a particular direction, how clustered or spread out the points are, and what the central tendency of the distribution is. While you can get a sense of this orientation simply by looking at the features in the map, calculating the standard deviational ellipse makes these trends clear. This is an example of a standard deviational ellipse for tornadoes in the United States. The map has a point representing every tornado that was reported in the US between 1995 and 2015. The map shows the mean center and standard deviational ellipse for the same set of tornadoes. The large black dot in the middle of the ellipse is the mean center of all tornadoes in the US during that time period. The ellipse shows us that during the time period, tornadoes were clustered in the Midwest and Southeast, with the mean center in southern Missouri. Directionally, there is a slight northwest to southeast trend. What other trends do you notice from the data here? To wrap up, spatial mean centers, weighted mean centers, and standard deviational ellipses are critical tools that help us gain insights into the spatial distribution of data and help us start to answer the question of what processes might be driving these patterns. We often use these tools in conservation applications to understand how species are distributed, but they are equally useful for other types of data as well.